All right. Today's lesson we have topic 2.5, segments, midpoints, and bisectors. In today's lesson we will be talking about the definition of a midpoint and the definition of a segment bisector. All right, so let's jump straight into this. Let me pull up our first definition. We should already know what this is from topic 2.4. But just in case, a midpoint is a point on a segment that is equidistant from both endpoints. So as a quick rundown of what that means is basically a midpoint is a point on the line segment that is directly in the middle. Both sides will equal each other. So let's look here real quickly at our example 1. It says find the coordinates of the midpoint of segment RS. Now I'm not going to draw the image that you have up here, but looking at that we can determine that R is equal to a -2. And then we look at S and we find that S is equal to a 9. So in order to determine what the midpoint of these are, we will add these two together and then we will divide by 2. So our R is -2 plus a 9, and then let's divide the entire thing by 2. Whenever we set this and do the arithmetic on the top, you will get a +7 over a 2, which let's go ahead and put into a decimal form of a 3.5. That is your midpoint. Now for example 2, I am going to give you a hint. If you look at the definition of a midpoint, that's going to say that you've got each side. So in this example, it's saying B is the midpoint of AC, so AB will equal BC since it is the midpoint. That's a quick hint to help you with example 2. Alright, so now let's look at example 3. Let me clear that out, and let's look at 3. 3 asks us to find the coordinates of the midpoint of segment EF, where E, and I'm going to write down here what we have E, and it gives us a coordinate of -2 and 4, and then it gives us F. Make that E look somewhat better here. Let me go ahead and erase that, but we can really tell. There we go. That's close enough to an E, and F is 3, 1. Alright, so in order to find the midpoint of this, we're going to do just like what we did in example 1. We're going to take our x1 and our x2, we're going to add them together, and then we're going to divide by 2. So if we're going to look at this, I'm going to go ahead and mark it for us. This is our x1. This is our x2. This is our y1, and this is our y2. In order to do this, let me go ahead and write down an equation, and I would suggest that you also write this down. We've got an x1 plus x2 divided by 2, and then you will have a y1 plus a y2 divided by 2. That's how we're going to find our answer. So let's use what we have up here and plug it in. So our x1 is a -2. -2 plus our x2 is a 3. I'm going to divide that by, not by 5. Divide that by 2. Excuse me. And here I'm going to look at our y1 is a 4. We're going to add our y2, which is a 1. We're going to divide that by 2. All right, so if you do this math right here, you will get a 1 over 2, and here you will get a 5 over a 2. So whenever we're going to actually go put this answer, we're going to find this actual answer of the midpoint. Here is our midpoint. Oh, that's midpoint. There we go. We're going to look at this and we're going to say 1/2. Well, that is a 0.5. And 5 over 2 will reduce, turn into a 2.5. So that is our midpoint. Okay, if you want to come up here and we're going to put in our formula, we've got our x m will equal this, and let's put our y m. That way we can keep up with that. And this will actually help you as another quick hint. If you take this right here and use it for example 4, put in what you know. In example 4, you will know the midpoint. You should know this and this. And you will know an x1 and you will know a y1. What you will not know are these. But if you put it into this formula and solve, you will get the example 4 answers. Alright, so now let's clear this out and let's pull up our segment bisector definition. Segment bisector is a point, line, or plane that intersects a segment at its midpoint. So it can be either a point, it can be an entirely different line, or it can be a plane, as long as it intersects a segment, any given segment, at its middle. So it's going to bisect it right in half. That's where you get a bisector. All right, so let's look real quickly at example 5. Example 5 says B is between A and C, and it gives us AB. Let me write this down here. It says that, let me go ahead and clear this. It says that AB is equal to 2y plus 6. And it tells us BC is equal to y plus 8. And it also tells us that AC is equal to 20. Find the value of y and determine if B is a bisector. Okay. So let's first, we got to determine y. And if I draw a quick line here, and I'm going to make this my segment. I'm going to put my, let me make a different color point here. Let's say here are my points. I'm going to say this is my A, my B, and my C. We know that all of this together is equal to a 20. We know that AB is 2y plus 6, and we know that BC is y plus 8. Alright, the reason that I like to draw these images is because now we can look, and what you can determine and make an equation out of this. You can say, well, this segment, this 2y plus 6, if you add that to our y plus 8, you're going to get our entire AC, which is 20. So an equation that you can create is 2y plus 6, because that's that AB segment, plus y plus an 8 should equal 20. We can use this to determine what y is equal to. Now, since we have a positive sign in front of both parentheses, we can take everything out without changing any signs. 2y plus 6 plus y plus 8 equals 20. All right, combine our like terms. 3y plus 14 is now equal to 20. Subtract our 14 from both sides. 3y will now equal 6. Y divided by 3 divided by 3. Y equals 2. All right, so now we've determined the value of y. That's the first step. It says find the value of y. So we can say y equals a 2. All right, we've determined that. Now it asks us to determine if B is a bisector. So if B was a bisector, if that right there was a bisector, if we had B was a bisector, what would we know about AB and BC? We would know that they were equal to each other. You could draw a line right here. If you look at that, and you could say, well, these things are congruent. That means they're equal. They will be the same length. How do we determine that? Well, we know what y equals, so let's see what our segment AB is equal to. Our segment AB equals 2y plus 6. Substitute in equals 2 times 2 plus 6. So let's go on. It's 4 plus 6. Now we can say AB is equal to a 10. Now you can do this one of two ways. You can say, well, is 10 half of what AC is equal to? In that case, yes, it is. But just to go ahead and continue on, some of these might not be so apparent. It's pretty easy to say, well, 10 is half of 20, so that means BC must also equal 10. Well, some of the numbers might not pop out in your head quite as quickly. So to go ahead and finish through checking this, I'm going to look at my BC, find a little clear area over here, BC, rewrite that, BC equals y plus 8, that should be real quick to substitute in a 2 plus 8, which is equal to a 10, BC equals to a 10. 10 and 10 are the same. We could say both of those are the same, so our answer is we have y equals 2, and yes, B is a bisector. That's what this wants to know. This wants to know two things. It wants to know what y is, and you have to solve for y in order to determine if B is a bisector. Make sure we name it correctly. B as a point is a capital B. All right. All right, so first you will work example 6. If you are having problems with example 6, we're about to work example 7 and 9, and that should help you with 6 and 8. Let me pull up a quick sketch of what you've got, because it says use this figure to answer examples 6 through 9. So let's look at example 7. It says on 7, it gives us that UY, I'm going to write that over here, UY equals 4x minus 3, 4x minus 3. And a YV is equal to X, YV. These right here are segments. YV is equal to an X. And it asks us to find UY and UV. Alright, so I am going to look at our figure. And let's go ahead and let's determine what we know about this figure before we try to answer any questions. It tells us WY, segment WY bisects segment UV at Y. If it bisects it, and you'll see these little marks, these little tick marks that are across the line, that's saying that these are equal to each other. So now we know that we can set a UV equal to a YV at any point in time, because Y, this is basically another line segment, and we're saying it's bisecting it, so that means we know Y is our midpoint. That is what we know off of that. So let's go down and let's look at our example 7. For example 7, I'm going to redraw another little quick sketch of what we've got, just so that way I can fill in where I need to, or what I need to write in what areas. A UY and a V. There's my UY and a V. UY is equal to a 4x minus 3, and YV is equal to an X. Now the reason I'm writing this down is so that way I can see the entire picture. I can see that it's not saying, well, UV equals something. That way it doesn't tell us the entire thing. I bet later on, one of these examples will probably have us do that. So what I know is this will equal this. So our UY will equal YV. So in order to solve for that, I'm going to put my 4x minus 3 equal to my x. And now simply solve. I'm going to move my x's to the left side, and I'm going to get my numbers by itself onto the right. So I'm going to subtract an x, subtract an x. That will leave me 3x minus 3 is equal to a 0. Add 3 to both sides. 3x equals 3. Divide both sides by our 3. That will leave us an x equals 1. Alright, so we know now that x equals 1. We can start to plug this in to find what it wants us to find. It wants us to find what UY and a UV. So a UY, it wants us to find from this point, this here, to this section here. So a UY equals, I'm going to go ahead, I'm going to go off to the side, and I'm going to plug that in. 4 times 1 minus 3 leaves you 4 minus 3. So our UY is equal to a 1. And it also wants us to find a UV. This is where you got to be careful. A UV, it wants us to find from this point all the way. We've got to find this entire thing right here. We know that this is equal to a 1. And we know this same side equals, you can either do the arithmetic right here of putting 1 in for x, or you can say, well, it's the exact same thing as this half. So the entire length in our instance would then equal to a 2. So there is your example 7 answer. We have UY equals 1 and UV equals 2. Alright, so lastly, let's look at example 9, still using our figure above. It tells us that UV equals an x plus, ooh, that's a bad plus 6. And then it also tells us that a UY, these are both segments, equals an x minus 1. Now it asks us to find YV. It wants to know what YV is. I'll put my question mark there for YV. Alright, so I'm going to draw my figure again real quickly. I'm going to put it up over here on this side right quick. I'm going to fill in. So that way I can look at exactly what it's asking for. U, Y, and a V, and it tells us UV, so it tells us this entire long section up here is an X plus 6, and it tells us a UY, it gives us a UY as being an X minus a 1. Alright, so now we've got to determine how to find what YV equals. We don't know what YV equals, our exact number. We don't know exactly what it equals. But first, we've got to figure out what this X is. Now, we do know this. We do know that our UY is equal to our YV. So in that case, we can say this right here. We can say, if we're going to plug this in, we can say we know we're going to equal, everything's going to equal our X, make a little bit better X here, an X plus a 6. We know that if we plug this in, let me write down a whole equation here. We're going to have a UY plus a YV equals UV. We know this. So this right here will be my UV. Now I need to put in a YV, and I need to put in a UY. And we're going to add those together. UY, we know that, is an X minus a 1. Well, if we know that our UY and our YV are the same thing, we can say, well, that is also equal to an X minus a 1. You can write it out like this, or we could simply say 2 times our X minus, X minus 1 is equal to an X plus 6. It's the same thing. You're going to add 2 of them together. It'd be the same thing as multiplying what you have by 2. Imagine this is a 4. 4 plus 4 is equal to an 8. A 2 times a 4 is also equal to 8. So either way you want to do it, if you like seeing it drawn out in front of you and doing the simple math, or if you don't mind doing the distributive property, either way you're going to get a 2x minus 2 equals X plus 6. Now let's do our simple arithmetic. I'm going to subtract an X. Subtract an X. It's going to give us an X minus 2 equals 6. Add a 2 to both sides. X is now equal to 8. Alright, now let's say, what is it asking us for? It's asking us for YV. So we know X, but we don't know the answer. We know YV, we plugged it in right here. If you look back, here's our YV. YV, let me go over here and I'm going to write this here on the side. YV is equal to an X minus a 1. So let's substitute in. We have an 8 minus a 1. That equals 7. So now we know YV is equal to 7. That is our final answer. That should help you, as long as on examples 6 and 8, if you haven't already done them, as long as you draw out exactly like I do right here, redraw your example, fill in what they give you. You know this portion right here, you know that UY plus YV equals UV. You know that all the way across the board, no matter what you plug in to UY, no matter what you plug in to YV or what you plug into UV, you can set up an equation and you can solve.